Hello all, let's just start part 2 of section 3.4. Still we are in section 3.4. In part 2, I will discuss first the properties of roots of polynomial function. What does it mean? There are two important properties about the roots of a polynomial, not function, because we are talking about the roots, polynomial equation. Okay, let's change function to equations. There are two main properties. Property number one: if a polynomial function, equation, is a degree n, then the equation has n roots. If your polynomial equation has a degree n, you have n roots. What does it mean? For example, x squared plus 5x minus 7 equals 0. It's a polynomial equation, correct? It's quadratic, but in general, the general name is polynomial, right? Polynomial equation. N, here your n is equal to, right? Your n is 2, the highest degree is 2. And you already solved quadratic equations, and you saw that you end up with two solutions or two roots, correct? Or, for example, if I have x to the power of 4 plus 3x squared minus 5 equals 0, this is a polynomial equation in degree 4. Then I will have 4 roots or solution if I solve. Correct? That's the first property of roots of polynomial equation. Number 2, there are two properties. Number 2, if a plus bi is a root of your polynomial function, is a root of I don't know why I'm talking always about functions, polynomial equation, then a minus bi is also a root of that polynomial equation, but here remember your b can't be 0, correct? The coefficient of I is not 0, correct? And you saw it when we solved quadratic equations. You saw this, that whenever you end up with imaginary roots or imaginary solution or complex solution, we named it on that time complex solution, you had two complex solutions, and they were a plus bi in the form of a plus bi and a minus bi, correct? This property is really important, really important. If you, for example, wants to write a polynomial equation, if they give you the roots of a polynomial equation, you can write the actual polynomial equation, correct? And we use this property to do that. The second important theorem that I want to talk in this lecture is the linear factorization theorem. Linear factorization theorem. If you have a function in the form of f of x equals an x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus a1 x plus a0, then you can say f of x equals an parentheses x minus c1 times x minus c2 times x minus cn. It's actually, if you have a polynomial function, you can write it as a factors in parentheses here, c1, c2, cn, they are numbers, correct? They are numbers, they are complex numbers, correct? Or maybe not complex always, in your book mentioned it's complex, but not possibly maybe real, correct? These are the factors of a polynomial function. It means this theory talks about that if you have a polynomial function, you can change your polynomial function, or you can write your polynomial function as a linear factors, because x minus c1 or x minus c2 or x minus c1, these are actually linear factors, correct? Because the power of x is 1 and we call it linear factor. Now, where we use, let's do an example where we use this theorem actually. Example number 1. Find a 4th degree polynomial function. Find a 4th degree polynomial function maybe function f of x. Let's also talk about variable. It means use x as a variable, correct? With real coefficients -2 and 2, with real coefficients that has 2 and -2, and I as a 0 such that let's say as a 0 such that f of 3 equals -150. F of 3 equals -150. They give you 3 zeros of a polynomial function, and they are asking you to write the polynomial function. In the first part of this lecture, I would give you a polynomial function and I'm asking you to find the zeros. Now, they're giving you the zeros, they are asking you which polynomial function has these zeros. Correct? If I use my formula, my theorem, I can write f of x equals an x minus c1 times x minus c2 times x minus c3 and times x minus c4. You may ask me why I stop with 4 factors and why I choose 4 factors. Because 4 zeros are given to me. Look here, they give you zeros, 2, negative 2, I. And I told you if you have a plus bi, definitely you have also a minus bi. If you have a complex zero, then on that time you have to take also a minus bi too. Correct? Now I can say f of x equals an x minus c1. c1 is 2 times x minus minus 2, which gives you x plus 2, times x minus I times x plus I. Let's simplify a little bit, right? Then f of x equals an, because I don't know how much is an, right? The leading coefficient. Look at here. X minus 2 times x plus 2. Can I write it as x squared minus 4? Difference of squares, correct? X squared minus 4. Also here you have x minus I times x plus I, that I can write it as a x squared minus I squared. Correct? But remember, our I squared is what? The value of I squared is negative 1. It means I can rewrite this as a f of x equals an parentheses x squared minus 4 times x squared plus 1. Correct? Minus minus 1 means plus 1. And now, if I here distribute like this, then I can write f of x equals an times x squared gives you x to the power of 4. X squared times 1 gives you x squared. Negative 4 times x squared gives you negative 4x squared. And negative 4 times 1 gives you negative 4. Let's simplify. Then I can write f of x equals an x to the power of 4 minus 3x squared, because x squared minus 4x squared gives you negative 3x squared minus 4. Now I could find this part. Now it's the time to find an. How much is the leading coefficient? How to find that? This part of the problem will help you, because they give you that f of 3 is equal actually negative 150. Correct? It means I can write here f of 3 equals excuse me, an times 3 to the power of 4 minus 3 times 3 squared minus 4. Or I can say f of 3 equals an times 3 to the power of 4 gives you 81. 3 squared is 9. 9 times 3 gives you 27 minus 4. Then f of 3 equals an. Simplify this. Negative 27, negative 4 gives you negative 31. Negative 31 minus 81 gives you 50. Okay, how much is f of 3? Look, the value of f of 3 is given to you. F of 3 is actually negative 150 equals what? 50 a sub n. To find the value of a sub n, divide both sides by 50. Correct? Then you can say a sub n is equal, how many times 50 goes to 150? Negative 3 times. Correct? Now, what is the polynomial function degree for? You had this. You had f of x equals an parentheses x to the power of 4 minus 3x squared minus 4. That was this. Now put the value of a sub n here. Then you can say f of x equals negative 3 parentheses x to the power of 4 minus 3x squared minus 4. Distribute negative 3. Then f of x equals negative 3x to the power of 4 plus 9x squared plus 12. That is what they are asking you to find. This polynomial function has four zeros. One of them is negative 2, the other one is 2, the other one is I, and the other one is negative I. Correct? That's the polynomial function they actually ask you to find. Let me do another example also for you. Example number 2. The instruction is the same as example number 1. Find a third degree polynomial function of f of x, but the third degree, not fourth degree, with the real coefficients that negative 3 and I. Negative 3 and I are the zeros. And f of 1 is equal what? 8. Now I want to set my function, my formula. F of x equals a sub n parentheses x minus c1 times x minus c2 times x minus c3. Why 3 factors? Because here I have I. If I have I should have also negative I. Then f of x equals an parentheses x minus 3, it means x plus 3, times x minus I times x plus I. Or you can say f of x equals an x plus 3 times x minus I times x plus I. I did it in the first example, gives you x squared plus 1. Correct? When you multiply. Now multiply these two parentheses, you can say f of x equals an, distribute x times x gives you x squared, x times 1, x times x squared gives you x cubed, sorry, not x squared, and x times 1 gives you x, 3 times x squared gives you 3x squared, and 3 times 1 gives you 3. Now, how much is f of 1? Let's find f of 1. F of 1 then equals a sub n 1 cubed plus 1 plus 3 times 1 squared plus 3. F of 1 equals a sub n times 1 cubed is 1, 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 3 is 8. Correct? How much is f of 1? They give you f of 1 in the problem. F of 1 is equal 8. Then replace it. 8 equals 8 a sub n. Divide both sides by 8. Then you can say a sub n is equal 1. Now, what was the polynomial function actually? You had f of x equals a sub n parentheses x cubed, which one was the plus 3x squared plus x plus 3 if I order it a little bit, right? Now, how much is a of n? Your a of n is 1. It means 1 times this function, which is x cubed plus 3x squared plus x plus 3. 1 times this gives you the actual parentheses, whatever the inside is. F of x equals x cubed plus 3x squared plus x plus 3 is a function that has 3 zeros, and the zeros are negative 3, I, and negative I. Correct? This was all about section 3.4. I'll stop the lecture and see you all in section 3.5.